So this is a PSPICE experiment. So in this experiment we have to simulate the common emitter RC coupled BJT amplifier circuit and study variation of gain at different values of RC and RL. Okay, so here we have to do whole this experiment on computer. So we are using this software ORCAD PSPICE. Okay, so show on computer. So what we'll do, we will open the software cadence, and here it is PSPICE AD Lite. Okay, we have to open this PSPICE AD Lite, and it will take some time to open. I think it is opened already, so it's not opening. PSPICE AD Lite. Okay, so this is the main software. Okay, so first of all it will be totally blank. Okay, so first of all we have to make a new text file. Okay, so here a blank page will open, and we have to type this whole code. Okay, starting from this sources line, we have to write all the way through this, and make sure to write each and every point. These all the points are also necessary. Okay, so we have to write in this order. And for our experiment, for example, in manual it is given 740 and 220. These R1 and R2 will be fixed throughout the experiment. Okay, so let's say we take it 640 and 220. Okay, so since we don't have time, so we are not writing the whole code, we are opening this code. Okay, so here it is. Let's change it to R1. Let's change it to 640 and keep it as 220. Okay, so first of all we have to vary R's. Now R1 and R2 will be fixed for whole experiment. Okay, and we have to change RC and RL. Okay, first of all we'll keep RC at 1 kilo ohm, and take readings at all RL. Okay, or alternatively what you can do, fix RL at 1 kilo ohm and change RC. Okay, so you will get these values. So let's do
Actually,
RL
let's
1
fix
kilo
RC.
ohm,
Let's fix RC and vary the RL.
then vary RL. Okay, so let's take it 1 and 1. First of all 1 kilo and 1 kilo ohm. Okay, so this is RC. It is let's take it 1 kilo ohm, and RL is also 1 kilo ohm. Okay, so we will just save the file, control plus S. Okay, simulate, then run. Okay, so you will get this type of curve. If this table is not shown, then what you can do is that you can command trace cursor and then display cursor. Okay, so since it was already there, so trace cursor and then display, so it will display the, and then we have to click on maximum gain. Here we have to click, and here the coordinates will be shown. So it is 12.512. Okay, now we have to note down this value here. Okay, so here it is 12.512. Now since we have fixed RC, now let's vary RL as 2.2. Okay, so we have to change RL to 2.2. Save it, control plus S, just I and then run.
You have to run every time.
Yes, so it is 17.204. You, as you can see here, earlier it was 17.203. Okay, so likewise we have to change, either you can fix RL and change RC, or you can fix RC and change RL. Okay, so similarly we have to make this whole matrix. Okay, so and after making this matrix, what we have to do, we have to make two graphs, one for gain versus RC and other graph for gain versus RL. Okay, so first of all this is the graph for gain versus RL. So on x-axis we have to choose RL, and for on y-axis gain. So first of all we have to choose three values of RL. Since here there are many values of RL, so we can't make all the graphs. Just we have to pick three values, or you can take minimum, maximum, and some mid value. Okay, so choose three values of RL and plot graphs. Plot this these three graphs will show this. This is for 1 kilo ohm. RC we have fixed 1 kilo ohm. Okay, for RC we have to note down all values of this RC for RL. Okay, so similarly we have to draw these three curves. Okay, then we have to, in second graph, we have to make RC versus RL. So in this we have to choose RL, not RC, because on x-axis RC is continuous. Okay, we have to choose three values of RL. In the previous graph we have chosen three values of RC. Okay, so here it will, here the graph would be like this. Okay, so you can choose any three values in which you get extreme and two extreme and one mid value. Okay, so this is all we have to do this experiment. So if when we make a new text file, at that time the it will, if we run it, then it will be whole blank. Okay, so it would be like this. Okay, when we run it, so let's make a new file. So we have to open this and make a new text file and just put anything, and then we have to save it as give an arbitrary name. Okay, and here save as type. In this we have to choose circuit files. Okay, here we have to click it, and we have to choose a specific location which we remember, like either we can choose any folder or we can just put it on desktop. Okay, so in on desktop with this name, save. Okay, now we have to just close this, and as you can see this is the our made file. And here, so here it is opened. Okay, now for to run this we have to simulate and then run. Now it is not running because it is not in proper
Valid code.
format.
It is not a valid code. Yeah.
It's not a valid code. So let's open this one again. So see, this file will run. Okay, so initially this whole will be black like this. Okay, so we have to add trace. Okay, then we have to here it is, we have to trace expression. So we have to click V6. Okay, then divided by, and then V1. Okay, this is our trace expression. We have to click OK. Our graph will be there. Now we have to trace, then cursor, then display. Okay, our value, we have to note this. This is our main value. Okay, this is gain 17.20.
Our gain is y1.
Yes.
Y1.
Okay, so that's all about this experiment.